Hello and welcome to section 5.6. Today we're going to be talking about um, symmetry and reflectional and rotational symmetry and whether that makes a molecule chiral or achiral simply by how you can um, do certain symmetry functions on those molecules. All right, so first let's look at rotational symmetry. And this is kind of a funny one because essentially what rotational symmetry is can you rotate the molecule in such a way that simply by rotating it, you can make the same image? Does that sound weird? Well, how about an example here? So let's take this molecule in purple, and right in the middle, let's put a little point in. And this point is what we're going to rotate around. So imagine that we're going to take this carbon here, and we're going to rotate it until it sits here. If you did that, what would you get? Well, I think you would find that you would get the same molecule, the identical image, right? And that's what rotational symmetry says. If you rotate by some angle, in this case 180 degrees, you get the same image, which means that there is an element of rotational symmetry present in this molecule. And this little point that we're rotating about is called the axis of symmetry. There we are, the axis of symmetry. But there's another type of symmetry you can have, which is called reflectional symmetry, meaning that instead of a point, you draw a plane, a mirror plane. So using this molecule, why don't we instead now draw a mirror plane down the middle, because that looks like it could be a reflection, right? And if we do that, then we know from experience that we can make the same image because these are both the mirror images, right? Well, in the last section, we had a similar molecule, and we said that if you take this molecule and you flip it over on its side, or sorry, if you take its mirror image here, the total mirror image of the molecule, not the one that we can make by making a mirror plane, but the total mirror image of the molecule um, if you take this, then you can actually superimpose it on the original, which means it is not chiral. So having a mirror plane gives you, if a molecule has a mirror plane in it, then it is not chiral, which is a big rule of chirality. If a molecule has a mirror plane inside the molecule, then it is not chiral. And that's something to remember because you can have both reflectional and rotational symmetry, but it's only reflectional symmetry that changes whether a molecule can be chiral or not. Definitely something to look out for, and it's important that you're able to determine if a molecule is chiral or not. So as a little practice of drawing a mirror plane, 5.23 in your book has some good examples. So we'll just work through one or two of those. So in 5.23 here, let's see, first it says we start off with Oh, that's a pretty bad cyclohexane. There we are. Two CH3s on a wedge. And it seems like pretty easy to draw a mirror plane right down the middle of that molecule like that. That's good. The next one is a bicycle. This is E. There we go. With both of these pointing down like this. And the mirror plane here can be drawn. It's hard to show this. Okay, so there's a mirror plane, but where does it cut through? It cuts through here. Right through the middle there. There we are. I would encourage you to look at 5.23 and other relevant problems in your book for finding mirror planes, because if you can draw a mirror plane, then the molecule is not chiral. This has been section 5.6.